Today we are discussing about Mealy machine and Moray machine. What is Mealy machine and Moray machine? What are difference between Mealy machine and Moray machine? How to convert the Mealy machine into Moray machine? How to convert the Moray machine into Mealy machine? And applications of Mealy machine and Moray machine. Finite auto may have output corresponding to each transition. There are two types of finite state machine that generate output. First one is Mealy machine, second one is Moray machine. Mealy machine. A Mealy machine is an FSM whose output depends on the present state as well as present input. Moray machine. Moray machine is an FSM whose outputs depends on only present state. Difference between Mealy machine, Moray machine. In Mealy machine, the output depends on the present state as well as present input. In Moray machine, the output depends only upon the present state. In Mealy machine, if input changes, output also changes. Moray machine, if input changes, output does not change because the output only depends upon present state. In Mealy machine, less number of states are required. In Moray machine, more states are required. In Mealy machine, synchronous output generation. In Moray machine, synchronous output and state generation. In Mealy machine, output is placed on transition because the output is outer side of the state. In Moray machine, the output is placed on state because the output is inside of the state. In Mealy machine, it is a difficult design. In Moray machine, easy to design. If take one example in Mealy machine, this is the state diagram of Mealy machine. First identify the how many number of states: A state, B state, C state, D state. This is the states. The arrow indicate the state goes to one state to another state or same state to indicate arrow symbol. This is input, this is output. To draw the transition table for given Mealy state diagram. First column to indicate present state, next column indicate next state. The next state split into input x is equal 0 and input x is equal 1. The input x is equal 0 split into two columns, state and output. In next column, the input x is equal 1, the split into two states, state and output. There are four states to indicate A state and B state and C state and D state. Initially, consider A state. The A state, if given input x is equal 0, the A state goes to same state. The output gives 0. In A state, the x is equal input 1, then A state goes to B state. The output gives to 0. Next coming to B state. B state, if input x is equal 0, the B state goes to C state. The output gives the 1. In B state, the input x is equal 1, then B state goes to A state. The output gives to 0. Next, C state, the x is equal to input 0, C state goes to D state. The output is 0. The C state, the x is equal to input 1, then C state goes to A state. The output is 0. Finally, D state. The D state, x is equal to input 0, the D state goes to B state. The output gives the 1. The D state x is equal to input 1. The same state goes to D state goes to same state. The output gives the 0. This is the transition table of Mealy machine for given state diagram. Next, coming to the previous example, Mealy transition table, we take how to convert Mealy machine to a Mnemonics machine. The first step, find out these states which have more than one output associated with them. We check A state. In column 2, the next step, we check A state. A state output is 0. In column x is equal 1, A state output is 0. In column x is equal 1, A state output is 0. So, the A state is single output, though there are no changes state. If check B state x is equal to 0 input, the B state output is 1 and x is equal to 1 in column, the B state output is 0. So, B state is two different outputs. B state x is input x is equal to 1, B state is output is 0. If input x is equal to 0, the B state output is 1. So, there are two different outputs. So, the B state is split into two states, B0 state, B1 state. If indicate B0 state is the output is 0 output and B1 state indicate output is 1. Next, coming to C state. C state, the x is equal to 0 input, the output is 1. So, the C state output is single, no change of C state. Next, D state. The D state, x is equal to 0 input, D state output is 0. And x is equal to 1 condition, that is the D state output is 0. So, D state is single output. So, the D state is no change. Step 3. Create an empty Mnemonics machine with newly generated state. For Mnemonics machine, the output will be associated with each state irrespective of inputs. Draw the Mnemonics state transition table. This is the present state, this is next state and outputs. This is the transition diagram of table of the Mealy machine. This is transition table for Mnemonics machine. The Mealy machine, there are 4 states, A state, B state, C state and D state. But Mnemonics machine, A state is same and B state is split two states, B0 state and B1 state. C state is no change, so say C state. D state is no change, say D state. In Mealy machine, A state, if input x is equal to 0, A state goes to A state and if input x is equal to 1, A state goes to B state. So, A state, x is equal to 0, A state, same state and input x is equal to 1, A state goes to B state. In B state is split to two states, B0 state and B1 state. B state, input x is equal to 0 goes to C state. So, B0 state and B1 state is same. So, B0 state is B1 state is same. B0 state is goes to C state, B1 state is goes to C state. Next, B state, input x is equal to 1, the B state goes to A state. So, B0 state goes to A state, B1 state goes to A state. Next, coming to C state. C state, input x is equal to 0, C state goes to D state. In input x is equal to 1, the C state goes to A state. 0 output. Next, B state is split in two states. B0 state is 0 output, B1 state is 1 output. In C state, the output x is equal to 0. In C state, the input x is equal to 0 condition 1 output. Finally, D state, the input x is equal to 0 condition 0 output and input x is equal to 1 condition, the D state output is 0. So, D state output is 0. This is the Mealy transition table to the Moore transition table. Coming to the Mealy transition table to Moore transition table is converted, then Moore transition table using to draw the state diagram. There are 5 states: A state, B0 state, B1 state, C state and D state. This is A state, B0 state, B1 state, C state and D state. The outputs are A state is 0, B0 state is 0, B1 state is 1 and C state is 1 and D state is 0. So, A0 state is 0, B0 state is 0 output and B1 state is 1 output, C state is 1 output, D state is 0 output. In Moore machine, the output is inside of the state. If A state, the input x is equal to 0 condition, the A state goes to same state. This is same state. If input x is equal to 1 condition, the A state is B0 state. A state goes to B0 state. Input x is equal to condition. B0 state and B1 state, the input x is equal to 0, the B0 and B1 state goes to C state. B0 state and B1 state goes to C state. The B0 state, B1 state, input x is equal to 1, the B0 and B1 state goes to A state. B0 state and B1 state goes to input x is equal to 1 condition. C state input x is equal to 0 condition, the C state goes to D state. C state x is equal to 0 condition, C state goes to D state. In C state, the input x is equal to 1 condition, C state goes to A state. C state goes to A state. Finally, D state, input x is equal to 0 condition, the D state goes to B1 state. D state x is equal to 1 condition, the D state goes to B1 state. D state, input x is equal to 1 condition, D state goes to same state. Input x is equal to 1 condition, D state goes to same state. This is the Moore state diagram. Let us consider another example, Moore machine to Mealy machine. This is the Moore transition table. This is the Mealy transition table. The Moore to Mealy conversion is easy to compare to the Moore to Mealy design. First, identify the states: A state, B state, C state, D state. There are 4 states. This is present state, A state, to indicate A state, B state, C state and D state. The A state input x is equal to 0, the A state goes to D state. Input x is equal to 1, the A state goes to B state. In B state, input x is equal to 0, the B state goes to A state. Input x is equal to 1, the B state goes to C state. C state, input x is equal to 0, C state goes to C state, same state. Input x is equal to 1, the C state goes to D state. Finally, D state. The input x is equal 0, D state goes to B state. The D state, input x is equal 1 condition, D state goes to A state. In Moore transition table, output is single output. That is, the output is dependent upon present state. Finally, in Moore transition table, the output only depend upon present state. But Mealy transition table, the in Mealy output is depend upon present state and present input. So, the A state output is 1. So, to indicate the A state output is 1. A state output is 1. B state output is 0. So, B state output is 0. B state output is 0. C state output is 0. So, to indicate C state output is 0. C state output is 0. D state output is 1. D state output is 1. D state output is 1. This is the Mealy transition table. This is Moore transition table. The Moore transition table, the output Moore circuit, the output is dependent upon present state, and Mealy output depend upon present state and present inputs. Finally, applications of Mealy machine and Moore machine. Mealy and Moore machines are both types of finite state machine that are used to model and digital design system. They are used in many applications. There are practical applications of traffic lights, a system that consists of multiple subsystems that works concurrently. Next one, vending machine, a simple software system that can be modeled as finite state machine. Microwaves, an example of Mealy machine. Counters, an example of Moore machine. Barcode scanner. Barcode scanner are an applications of Mealy and Moore machine. Gas pumps. Gas pumps are an applications of Mealy and Moore machines. Digital clocks, an example of Moore machine. State machine controlling a video game character behavior, an example of Moore machine. These are practical applications of Mealy machine and Moore machine. This is the briefly Mealy machine and Moore machine. How to convert Mealy machine and Moore machine to Mealy machine and applications of Mealy and Moore